All right, we're going to talk about Apache Spark, streaming, feature development, insights, and stuff like that. Just a brief introduction. I started my big data career at FINRA. At FINRA, I built the largest graph database in the world, and I think it still is the largest graph database in the world. It records every movement of every stock in the United States between any storing location. And it puts that into a graph database in real time. So that was an interesting one. And from there, I moved on to Cloudera. And started Cloudera in around the 200th employee. Stayed there for about 4 years. Essentially just checked out after that and decided to live the dream in SoCal and work for a game company. Did that for 2 years. In the meantime, I wrote 2 books. They're on the side. There's a third one coming, hopefully in the next couple months. And then I worked at Blizzard for a while, where I learned a different perspective on big data in terms of mass amounts of IoT data, streaming at scale, delivering that data to customers, and then at the later part of my Blizzard experience, directing the analytics and engineering department to support machine learning. And then moving to Capital One, started off as an architect over there, and now what I'm doing is reinventing the way that all the data moves within the company, which is very cool. And hopefully we'll be delivering it soon and having a talk on how we did it. So what we're going to talk about today is we're going to talk about where Spark can fit into your data ecosystem in terms of streaming and feature management, right? I'm not going to go super low into detail unless you ask me. And then in some sections, I'm not going to go into super low detail until I finish that project, and then we're going to share more later. So the first thing we're going to go into is vocabulary. Why? Because words are hard. Words are harder than most engineering problems. We're going to talk about what is features, feature collection, entity-centric ideas about that, feature management, inner and open loop execution, streaming and batch streaming. So the first thing, and it depends on what your company is and how your company deals with words. Capital One was one where this word was actually kind of interesting. And the more people you talk to, people have different definitions. My definition is really simple. Feature set is data, and datas are features. You feed features to train models. You feed features to models to execute to get a result. Some of these features are derived and some of these are sourced. You may have a different definition of features, but this is where I'm going off of, okay? There's nothing magical about features. They're data. They may have extra metadata on how the feature was generated or extra metadata on where the feature came from, but it's just data, okay? So entity-centric features is this idea where, let's say you have an account ID, right? Or from a gaming perspective, you have a gaming ID, and you can say, this is how long they've logged in. That could be an aspect of that person. This is their churn likelihood over time. This is their preferences of what they might want to see in an ad profile. And entity-centric data structures are such where you could query based on the gamer ID and get any of these aspects back in very, very low latency. Typically you use something like Redis or Cassandra to back these up. But you could also store these same attributes in a nested data structure, maybe in S3 or something like that. The use case we used for the nested data structure that I had done a long time ago was for a company called IMS. They publicly announced how they did it. They were able to do machine learning over 300 million people for every drug that they ever took. Within minutes, because they wouldn't have to do any joins. Everything was already organized in this entity-centric idea. Next word we're going to be talking about is feature management. I'm not going to go too much in here, but we could have an entire course on the whole idea of you need complete auditing, you need complete protection, you need complete governance, and you need complete tokenization. Anybody who understands the California laws and the European GDPR laws understands that this is just part of their life now. And uses training, obviously reading the data, putting it into the model for its training cycle. Different models have different ways that they consume data and train. Inner and outer loop execution, which we'll talk about in a minute. Insights is whatever you learn. This could be graphs, this could be a report, this could be an alert that's telling you to change the way you behave. And then there is research, just ongoing, like continuing to dig into things. Inner loop and outer loop, there's several ways that I've heard this described. Some will call it asynchronous or blocking execution. Some will call it asynchronous or non-blocking execution. And the idea here is imagine the inner loop to essentially be, if I'm going to swipe a credit card, it's a decision I have to make before I allow you to finish your transaction. And then an outer loop is, I swipe your credit card, and maybe I don't do the work in between the transaction, but later on I give you a call and say, oh, by the way, I know you live in California, but you have a whole bunch of purchases in Russia. Is that you? That kind of a thing. So there's inner loop and there's outer loop. And traditionally, with streaming, you're thinking about outer loop, right? You're thinking about this way where data is coming in through a stream, and you're reacting to either joining multiple data sets together and then sending on a reaction through a stream somewhere else. Okay, and in terms of execution, especially when we talk about Spark streaming, I love that capital U. You can tell that I made the slides today. So with execution, you can have inline. With Spark streaming, you can have the ML execution being executed inside the JVM. That may not be what you want to do. Maybe you're using something like TensorFlow, and you actually want to send out a request. You send out a batch of features off to a TensorFlow cluster so that they can give you the results back. Or maybe you actually just want to send off those features asynchronously to Kafka to be executed by a model later on, because the model doesn't need to do the state management that you're doing in either Spark streaming or something like that. Sorry, I'm getting a phone call. I am actually speaking in front of like 100 people. Can I call you back?
Oh, okay, I guess.
Okay, I'll talk to you later. Bye. All right, very cool. All right, let's keep going. Streaming. Streaming is one of these things where it sounds really simple. What is streaming? But people really don't get it. So first off, streaming is just record-based. Records go through streaming, okay? So sometimes you'll hear people say, why can I stream Avro, but I can't stream Parquet? Parquet is a file. And Avro can be a file, but it also is a record format that you can serialize over the wire. The other thing that people get hung up on is streaming versus microbatch. And I hate to tell you this, but everybody microbatches. Everybody microbatches. Flink microbatches, Spark streaming microbatches, Spark structured streaming microbatches, what's the Dizzle or whatever, microbatches, and Kafka, when you consume from Kafka, microbatches. And why? Because batches go faster than single record reading. It's just part of life. Where do we distinguish what is streaming and what is not streaming? It's an imaginary line that each of us draw on how many milliseconds we consider to be acceptable for streaming. Typically, when people talk about streaming use cases, they're talking about underneath 100 milliseconds. That's most of the time. But when we start adding in event time processing, how many people here are doing event time processing? Okay. From that point, you've already screwed yourself on that latency because you got to wait anyways, right? Because you can't move that fast, otherwise you're going to get in trouble. So what is streaming, right? Streaming is this, the way I talk about it is it's event level. Things are coming in event level. Other thing for input types, we're going to be talking today about different types of input types. Low latency, high latency, and logical produced input types. Low latency is your IoTs coming from devices. Could be coming from a stream from a different application you have. High latency is files. So I'm actually a big proponent that if you get a file, and the majority of most companies, we're on the West Coast, so you guys are way more advanced. Everything is streamed on the West Coast, I've heard. But on the East Coast, a lot of things still arrive in files, maybe hourly or daily or whatever. There is still a lot of value from taking those files and putting them into streams. And a great way to do that, we'll talk about it a little bit, is Apache Spark. And then logical publishing, again, SQL, Apache Spark, traditionally ETL tools that I hope none of you still have to use. But yes, those are ways we can input data into our streaming platform. Outputting data, there's really three modes here. We have low latency. This is consuming straight off the pipe, maybe. There's higher latency. So how many people write data to an object store or HDFS? All right. you really can't stream to HDFS. You batch write to HDFS. And this is that example. You take a whole bunch of information and you batch write it, right? And then there's the push model. So when I was at Blizzard with these guys here, we had built a tool with Overwatch with Twitch, where we received sessionized data from Twitch. They had a stream of who was connected. They would send that data, push it to us through an API. We would register a REST endpoint or whatever, or a gRPC endpoint, and they would send that data to us. It's a little bit different model. You're not as much of control, and if you're not home, well, you're not home. You don't get the data. You have to go back and either maybe go through a different route or do a special request, right? So these are ways to consume. Any questions so far? Have I made anyone upset with my definitions of words so far? Okay. You never know. People get really touchy about words. Okay, then we're going to talk about streaming output types. And this first one is where if you're a Spark fan, Spark streaming fan, you may get upset. There is stream processing that does not require state. If you have stream processing that does not require state, you do not need a Spark streaming or anything like that. You can survive with a microservice and you'll be fine. And that is the majority of use cases, honestly. Now, if that's not what you need, the next one is streaming with state. We're going to talk a lot about state as we move on, sessionized state, tumbling window state, sliding window state, stuff like that. And then you do your processing and you send out information. And then the next one is state for state's own purpose. This is this new idea that has been coming up in the last couple of years in that the state in your streaming platform system can be queried directly with like SQL and stuff like that. And Spark has that ability. And we'll talk a little bit about should you do that or not, right? And maybe that works for you and maybe it doesn't. This was an extension off of the batch streaming. When you batch in files, one of the things you need to consider is some people actually might still want the context of the fact that that came from a file. You might need to include metadata in terms of the file name or the file time it arrived, and then maybe the line number and stuff like that. And Apache Spark actually offers a really neat way to do this in a really fast parallelized way. One of the things you can do is you can, when you read the file, you immediately do a count of all the records in the partitions. And then the next thing you do is you broadcast those counts back out to the partitions, and you can get a unique ID for every record in the file. And then you can supply the file name with the unique ID to every record so that when it eventually lands in maybe something like a SQL database or an Elasticsearch, you can say, show me all the data that came in with that file, and you'll have access to it, right? All right, big picture. Let's talk about the ecosystem. All right, this is the world. This is it. I know it's a really crappy picture, but this is everything. So let's talk about the different parts, right? So the first part is that big green thing in the middle that I'm not going to talk about right now. The big green thing in the middle, several companies have different implementations of that. Me and my ex-Blizzard comrades, we had one at Blizzard, which we called telemetry. Netflix has talked about one which is called, what's the name of it? The big one. I forget the name of it. It was some big pipeline thing. And Capital One has one as well, and that's what I'm building out. And so what should a pipeline do? And a lot of people have different beliefs of what a pipeline do. If you go get the Confluent definition, you have a schema repo, and every schema goes into its own unique topic, and that's pretty much it. And then you treat topics like tables. I'm not a big fan of that. I don't think it scales well, and so we don't do that. But what do I believe a streaming platform should be able to do? First, it should never go down. Publishing to a streaming platform should have higher resiliency than any other application in your company. At least that should be your goal. And right there, based off of that, pure Kafka does not qualify. So you have to have something better. I'm not going to talk about how we did it, but it has to be never going down. I believe it shouldn't lose data. Now, you can build systems that lose data and you can save some money, right? But you don't have to, and still you can do a good job. It's going to be record-based, like we talked about, and it should be able to accept almost anything. I think it should be able to accept HTTP, gRPC, syslog, straight from Apache Spark data frames, data sets, and that should just be trivial and easy. Any questions to that? All right. Next is it should validate schemas. It should validate any rules that go along with those schemas. It should do tokenization and more magic we're not going to talk about. Does anybody have any questions on that slide, or does that make anybody feel sick? All right. The idea is if you have one of these then, is you could tell your company, send all your data here. Because it's up all the time, or up higher than everyone else, it's a safe place to send your data, and now you have lineage. And we're going to talk about now all the places where it can deliver your data. It can send all your data to maybe your S3, maybe your BigQuery, maybe a NoSQL database where you can do entity-centric data structures, maybe Elasticsearch, maybe to your stream processing. But what it allows now is one place to go in and one way to see where it's going. Very convenient in the world of auditing, and also convenient to your producers, because now your producers don't have to care what your analysts need. Okay? All right, inputs, we already talked about these. So where does Apache Spark fit in with the inputs? Well, I guess you could put Apache Spark Streaming in front of streaming inputs. That's possible, right? And maybe some of you have done that. I have not done that. So that's one of the ones where I'm like, it's an iffy one for me. Batch file processing to a streaming platform. I actually think this is a wonderful pattern, because what I can do to any of the producers is just say, get your file into a way that I can consume it from a data frame or data set. So working from a bank, we have to consume things called copybook files. And if you've worked, how many people have ever heard of a copybook file? 1 person, 2 people, 3 people. Okay, copybook files are terrible. They were written back in the IBM mainframe age. They're disgusting. But you can put them into a data frame. And if you can tell the producer, get your data so I can read it into a data frame, you don't care after that point. You can consume a data frame. And that's one of the wonderful things about Apache Spark. So that one, I would highly recommend it there. The logical generation, I think Apache Spark is wonderful for ETL and machine, feature prepping jobs and stuff like that. It's super robust. It's super dependable. I'm not trying to sell Databricks, but their UI and their experience is pretty nice. But if you don't use their UI, there's other notebooks out there, right? But the idea is it's a really great way to create features, and then if you already have that data frame plugin, you're good to go, right? I'm not saying it's the only thing for logic generation, but it's not bad, all right? So in terms of pushing, where does Spark fit in? I mean, in terms of publishing. For pushing, I don't see where it could fit in at all, honestly. For streaming, we're going to talk about maybe Spark Streaming for streaming. How many people, and I'm just curious, and I know this is a Spark event, and I hope I don't get in trouble. How many people use Spark Streaming? How many people use Spark Structured Streaming? How many people use Flink? How many people use Kafka Streams? Interesting, interesting. All right, all right. All right. I'm not going to tell you which preference I have. All right, and then for batching, we're going to go into, does anybody know what a long-lived Spark application is? A long-lived Spark application. Has anyone ever used a single driver and fired off 2 DAGs in separate threads? Had anybody, who hasn't ever even tried that? All right. All right. So there's a trick. If you're going to learn anything from this entire thing, one of the things you can do with batching, like let's say you're writing test 3, let's say you're writing to some high latency system. You could spin up a Spark application for every single time you fire that off. And you would essentially be using Yarn or Mesos or Kubernetes or whatever your flavor of choice is to spin up those executors and then fire that data off. But maybe you want it to happen more frequently. Maybe you want it to happen every couple minutes. Well, the data that's coming through for every single table, some of the tables may be really small. It may take longer for you to start up the Spark job than for the data to actually publish, or to actually go and look up all the file locations, and then them actually doing work. So we're going to talk about that, but you can essentially have a long-lived Spark application. We're going to, let me go to the image real quick. You can have a long-lived Spark application where you can send multiple requests into the driver, and those requests can live within different threads, and they're all firing off concurrently. And what will happen is the executors will use the tasks to take up the workloads so that you're switching between workloads at the fastest rate you possibly can. Does that make sense? All right. So if you don't believe me, this is ready. If you've ever used the Databricks product, this is how the Databricks notebook interacts with Apache Spark. It actually is sending multiple requests to the back end, the same back end. It's not spinning up a Spark application every time you send a new request, right? So this is a great way to do a lot of ETL with a little bit of resources and remove all your startup time. Any questions on that one? This is just a diagram showing that the majority of the time your Spark application is up, there's a lot of tasks that are actually not doing anything. Now, if you're doing a giant job, yes, all your tasks are doing work. But if you have to repartition at any point and things aren't doing work, that's just wasted money and wasted time, right? All right. And another nice thing about this is put it behind a load balancer. And then if you run out of resources, you just spin up another cluster. And you just spin up another cluster. And you can just do more and more and more and more requests. Super nice pattern. Okay, let's continue. So the next idea here is a streaming database. So what is a streaming database? So, the Flinks and the Sparks and the Kafka, the K-SQLs are marching toward this kind of streaming database. We're going to talk about it from the perspective of Spark streaming. So when data comes in, right, you get to control what's in state. Now, you can use their fancy pretty methods that are I want my window to be this big, and I want to tumble by this, or I want to slide by this, and that's totally fine. But Spark also comes with another method we're going to talk about called map group with state and flat map group with state. And in that, you get to control essentially a key value store any way you want in terms of how the data gets persisted. You can trigger off data mutation, and the data can age out. And you can query the data with SQL. So it's kind of like an in-memory database that is optimized for mutations and triggering, which is a little bit, but while I was preparing for this, I was like, what other database is like this that is really good for this? I don't know. I don't know of one that is optimized for triggers on insert for mutation and optimized for triggers on action based on state of the mutation. And that, I think, is the selling point of something like a Spark streaming, right? It offers that state that you can do things with. So let's quickly look at an example of map with state. How many people have used map with state? Map group with state? No one? How many people have used Spark streaming? Okay, so not that much. You guys haven't used it either? Oh, you have used it. You just didn't want to raise your hand. All right. So the idea here is this method starting at line 4 or so, does not get called unless there is a new record with the key for that data set. So every data set has a key. It's grouped by a particular key. Then it has, so this is the key. This is all the events that happened within the last batch for that key. And then this is the current state of that key. It could be empty. The current state could have nothing in it, or it could have something else in it. And then you get to decide what then goes into the current state. What we're doing here is we're doing a word count, right? So we only keep a single account into that state, so our state can stay very small. Another example is the one that we did at Blizzard with Twitch, where they sent us, every minute they would send us through their public API, who is watching which stream, right? So if they send us something, who is watching which stream every minute, you could store all those minutes, and that's going to become extremely expensive. Or you could just say, I'm going to store the starting point of the session and the ending point of the session. And then if there's a gap, then I'm going to let it go, right? And you can do that with this function. And then at the very end, you get to return whatever values you want. This doesn't limit you also for making calls out based on triggers to Kubernetes, or not Kubernetes, TensorFlow, or other modeling systems. But this is a decent model for putting your features together in a low latency environment and then triggering model execution off those features. Now, on that one, yeah, I have some pet peeves. So I know, is anybody here from Databricks? Okay, one person. Okay, jot these down, because I want these. First, group with state will only be called when you have a new method, or a new record for that key. And that's good, I get that. They're trying to save on execution time. Makes sense, good for them. Then, group state timeout will allow you to remove state after a given time. And that's good too. If you're doing sessionization, you don't want your data to be there when the session has expired. What it doesn't give me is a trigger on that expiration. Maybe I want to fire an event when you leave. Maybe I want to trigger something. Maybe I want to record the state to a database at the end of a session. I don't get that here. So what I need to do now with Spark is I need to send out a message to a Kafka topic or something, and then reconsume it at a later point in time and say, hey, now that I've waited this period of time, is this session still valid, to try to then use that to close it as opposed to use the functionality in Spark. The next one that I have a little pet peeve about is there's no broadcast joins in Spark streaming. Does everybody know what a broadcast join is? So broadcast join, right, is you got a little bit of data, and you got a lot of bit of data. And you can essentially in Spark streaming, one model is if you do a join, that little bit of data gets multiplied to the bigger bit of data and then sent out. And me and Tara here, we experienced that. And essentially what that happens is it lives in one partition, and then it gets multiplied in one partition to the point where it blows up. It doesn't even go past that, right? And so, there's tricks you can use. The trick we had used was essentially we had to group users into mini partitions, and then we broadcast to the mini partitions. Another approach you can do is your broadcasts go out to a Kafka cluster independently of Spark streaming, and then you have every executor listening to the broadcast cluster. So you're kind of building your own way of doing it. But those are two features that I would love. Can you add them? Thanks. It would be great. Because they're very common. Think about if you're doing sessionization and an event happened, somebody made a touchdown in a football and you want to give everybody a free pizza if they were watching at the time that the touchdown happened. This is how you would do it, right? If you want to do it in real time. If you want to do it later on, you can run a query. We already talked about model execution. And then the high latency, we had talked about this. Good, we're doing good on time. Where you can do multiple jobs. Okay, so with that, just closing up. So, with that, our streaming platform environment, we can get, our inner loop and our outer loop. Oh, we didn't talk about this one. Can you see my pointer? Let's talk about that one. So we talked about being able to do outer loop execution. That is doing execution of a model on a trigger. right? So your feature has been made inside the data like Spark Streaming, inside the state of Spark Streaming. Then you trigger the model. That's a asynchronous or outer loop execution. But how do we support inner loop execution, right? So when we have our Spark Streaming application and we find that we changed our session data to enough that we want to report it, we can report that to like a NoSQL or a Redis, and then that is offering now our inner loop, our blocking calls to be able to reach out, grab that data in real time, and then make model executions off that. So our streaming platform can be used, our Spark Streaming platform can be used to create those features in real time and populate these index systems. And one approach that I've seen for this model building is to essentially reuse Spark applications and inject the feature construction logic so you can reuse one job to create multiple features. That's pretty much it. So that's everything. We have a couple minutes left. Is there any questions? Other than that, I get to head out.
Please, so that everybody can hear them and they get recorded. This mic. Yeah. If you have any questions, please come ask.
Hi, Ted. So I guess the only question I have is, you're building out this new data platform at Capital One. What were the considerations for, I guess, bottlenecks from getting from the producer to the consumer?
So so any considerations of a streaming platform, let's say hypothetically we started at Kafka, right? And let's say we're using the Confluent Kafka, right? Because that's probably one that most people are familiar with. Because Kafka itself is actually a very fragile beast, right? You can do a denial of service from the producer side. You can do a denial of service from the consumer side. If you're using the Confluent model where it's topic per data set, it's essentially like building streets for every type of car on the road. So you have a street for a Cadillac, a street for a Tesla, and a street. So if you all of a sudden everybody's buying Teslas, that Tesla road is in trouble, right? So there's a lot of issues with that. And then it's a high consistency system, so if you lose a broker, it could impact performance, and it could impact producers' ability to write. And then even if everything else that I said is make-believe, I've experienced people, real companies, experience multiple hours of downtime unable to get their Kafka clusters back up, okay? Just because of zookeeper issues and stuff like that. So the idea was maybe Kafka's not perfect. And now there's Pulsar, and there's PubSub, and there's Kinesis, and there's all these other things. With what I was talking about in terms of the high-level requirements, right? Maybe we don't have to couple all of our producers to the flavor of the month streaming platform. Stuff like that. There's many more that go with that, but those are probably the higher ones. We never want, in building a streaming platform, the producer should never be interrupted. Let's just say like in a video game company, if your producer is the game server that's sending data, you don't want them to air out because they couldn't send you data. You don't want them to have a crap load of buffer on their server because they couldn't send you data. And if you're grabbing data from a client, like a mobile client, what are your expectations of this guy to do that, right? So the uptime of the producer has to be as close to perfect as possible. Is that, yeah?
Mm-hmm. Yep, thank you.
Hi, great talk. I think I have a question about the example you just gave about the word count.
Yes.
It seems the state is kind of kept in memory.
Yes.
So what if the application actually dies? Do you kind of lost all this kind of intermediate state?
So this is one of the advantages of this streaming database, right? And a month ago, I heard that Kafka Streams doesn't do this, but Spark Streaming has been doing this since the beginning. They have a checkpointing mechanism that can fire at the times you care that it fires, right? Like you can tell it how often to checkpoint. But unlike a normal database, like look where we are, like a Cassandra or something like that, that always has to be writing to like a write-ahead log. Spark Streaming doesn't have to do that because it has Kafka or whatever it's consuming from. So what it can say is, I'm going to checkpoint every once in a while. And then I can always go back to the stream and replay to catch up. So it actually gets the opportunity to touch disk fewer times than a normal database would, and still have consistency.
All right. Okay. Thank you.
And also with Spark, it actually will store a whole bunch of them, and you can return at different points in time. Now, the one thing that I ran into, and you got to be very careful of, is if you run out of memory, what might happen, and it's happened to me multiple times, is the writing of those files can get corrupted. And if enough of them get corrupted, you're screwed. So yeah, don't do that.
Hi. I was hoping you could talk more about the long-running Spark application.
Yeah, so it's super dumb. It's super easy.
Do you set up like an HTTP server?
I spin up a Jetty.
Do you really?
With a stupid little REST server in front of it, and I give it commands.
I'm so mad because I brought that up at stand-up, and they all looked at me like I was dumb.
So if you have a situation where, let's just say, hypothetically, you need to run 100,000 Spark jobs a day, and they're all doing the exact same thing, and they have varying levels of the amount of data they need to do, and they're all relatively simple. Like, you wouldn't want to put people's arbitrary code into the same application. Maybe they did something stupid, right? Like they did a collect and they brought everything to the driver. You would want to be careful of that. But if you had a bunch of jobs that were similar, that were firing all the time, it's ideal. Yeah. And it's just so much better use of resources. And the idea of scaling up per cluster, you don't have to worry about dynamic allocation. You don't have to worry about any of that stuff. It just becomes so much dumber.
Have you done that on a managed service like Databricks? Or?
Is it okay for me to say no? Yes, no.
Okay, that's right. Well, thank you.
No.
Thank you for the talk. You mentioned that if you're storing state in a stateful streaming job, it's possible to reach into the state store itself and run SQL on that.
Yeah, so because of the way Spark is made, right, all that stuff is getting stored and manipulated with like Catalyst or whatever, and you can use SQL to access it. Afterwards, I can even show you examples that I have on a training GitHub that I have. Essentially, when you write your Spark streaming job with structured streaming, I don't think you can do this with regular, which, by the way, Spark structured streaming is a terrible name. They should have came up with something better. It's too long. The idea is that structured goes into like a data frame or whatever that you can query with Spark SQL. And there are ways, I haven't done it, but the Databricks guys have shown me it working, that you can set up like a JDBC server in front of it and connect to it externally.
So the external connection bit was,
yeah, talk to them. I haven't done it, but they showed it to me. So I know it can be done.
Thank you.
The worry that I have with that, though, is people tend to write bad queries for some reason. I don't know why, but, and I don't know if you want bad queries running on your streaming platform. So that's the only reason why I haven't actually done it.
Thanks.
Hi. Currently, we cannot choose between Flink and Spark. So my question, when we should use Spark and when Flink?
I have to be very careful here because I was invited to speak here. I would say they both have different advantages, right? The advantage I would say that Spark has is they have a much higher adoption rate overall for Spark, not for Spark streaming, but for Spark, which means it's easier to hire people for Spark. And also, you may have a high skill level for people that know Spark, right?
Spark seems much easy for us because we already have
That's what I'm saying.
experience.
So you already have the infrastructure, maybe you're already paying Databricks some money, then you're good, right? And then what I would say is just stay with Spark Streaming.
Okay, thank you very much.
Yeah. See how I got out of that? Yeah.
All right, guys. If there's no more questions, Ted, thank you.
Thank you.
And see you guys later.